Hey guys, I want to go ahead and do a couple of half-life problems just so you guys kind of get an idea of how to do these. Remember, these are an extension of your compound interest. So we're going to start off with this. If you take a look in the other video, I kind of go over how we got this formula. So anything that's half-life, something that decays, something that grows, bacteria, viruses, something that's growing continuously, that it doesn't stop, we're going to use this formula here. And half-life has to do with chemical elements, and so they're always continually decaying, or something is happening to them. So when I see half-life, I already know I'm going to use this. So it says that a hospital prepares 100 milligrams of technetium-99. Okay, and it tells us the half-life is 6 hours. So this first question is like level 1, and it just kind of breaks down each step. And then I'll do another one which is a little bit more straightforward, and we'll go through that one. But it says, what's the decay factor? Well, the decay factor is this guy right here, K. Okay, that's what the decay factor is. So this is all they give us. Well, how do we do it? Well, we got to figure out this K. A is the amount. A sub naught or A sub 0, that's your starting value. But, okay, it tells us 100. And then it tells us the K we're trying to figure out. And then the T is the time in hours. Well, here's how we do it. It says, what's the decay factor? So we know that the half-life is 6 hours. And when you're starting to do these problems, usually you're going to have to find K first. Okay, so when it gives me the half-life, this is how we would do it. We know that, you start off with 100 milligrams, right? Okay, that's what you start off with, 100 milligrams. Okay, and actually over here we should put it, but let's say normally we should do A amount, A sub naught, and then we should do K, and then we should do T. So the amount is, well, we don't have that. We know that it gives us 100 milligrams. That's what we start with. Now it says that the half-life is 6 hours. Okay, that means in 6 hours, half of this is going to be available. So that means we're going to have 50. You see how I did that? So if we start off with 100, okay, in 6 hours, we're going to have half of this, which is 50. So I can use this information to figure out my K. So we have 50 here, E to the K, and then times 6. Okay. All right, so then what I'm going to do now, I'm going to divide by 100. Okay, so divide both sides by 100. Okay, 50 divided by 100, be careful, it is not 2. Okay, it would be 1/2. Let me do it up here. And then we're going to have E to the 6K. Okay, so notice how I did that. So divided by 100, I got 1/2, and then E to the 6K. So remember, we start off with 100. It tells us that the half-life is 6 hours. What does that mean? That means in 6 hours, I'm going to have half of this, which is 50. Okay, so now we have this. Well, what do I do? How do I get this K down? Well, remember, you're going to have to use your properties of logarithms. Now, because it's a base of E, you're going to have to use ln. ln of 1/2. And then you're going to have to do the same thing on the other side, ln of E. Okay, now remember, power rule. Okay, now that I have a log and a power, this guy can come to the front. So now I'm going to have ln of 1/2 is equal to 6K times ln of E. And remember, ln of E is equal to 1. So you're just going to have ln of 1/2 is equal to 6K. Well, what do you do now? Well, all you do is divide by 6. Okay, so K is equal to ln of 1/2. We're dividing by 6. And that should give you approximately, let me see, negative 0.1155. And it makes sense. It's a negative because it's decaying, right? It's going down. So it would make sense that the K factor is negative. So that's it. That would be my K factor. So what did I do? Start off with labeling stuff here. Everything that you need. Okay. So these half-life problems, you're always going to use this guy right here. Okay. Let's go to part B. It says, what is the length of the half-life? This seems like a tricky question, but they already give it to you. What is the length? That means how long. Well, check it out. It's right there. 6 hours. That's the half-life. 6 hours. Okay. Let's go to part C. Write an equation to represent this problem. Okay, so we want a model that will represent the generic rule for this situation. So remember, we start off with this guy right here. So we're going to write A sub naught is 100. E, because it's continuously decaying. Our K factor is this guy right here, our negative 0.1155 to the power of T. Okay, that is the equation that'll help us solve any of these problems. All right, cool. That's part C. Now it's asking us, okay, find the amount of technetium-99 after 75 hours. Well, what do I do now? Just plug in that 75 in there and use my calculator. So let's see here. A is equal to 100 e to the negative 0.1155 times 75. And all I got to do now is just plug it into my calculator. So if I do that correctly, let's see, I should end up with approximately 0.0173 milligrams of technetium-99. Okay. And that's it. That's it. So hopefully that helps and it makes sense. But let's go ahead and do another problem that's a little bit more direct and something that you'll see on a quiz or an exam your professor would give you. He won't break it down at all. It says phosphorus 32 is used to study a plant's ability to use fertilizer. The half-life is 14.3, and it says write the exponential decay function for a 50 milligram sample. And then it says find the amount of phosphorus 32 remaining after 84 days. So it's a half-life problem. I know that I'm going to use this guy. So what do? Well, let's start labeling stuff, okay? A sub naught, and then you have your K factor, and then T. Okay, so what does it tell us? How much do we start? We start off with 50 milligram sample. That's what we start with, okay? Then it doesn't give us our K factor, okay? But it tells us that the half-life is 14.3 days. Now remember, with a lot of times when you're solving these problems, you're going to have to find K first. You're going to have to find that growth decay factor first. So K is equal to, we don't know. So let's see, we know the half-life is 14.3 days. Half-life, so half of 50 is going to be 25. Well, with this information, I'll be able to find K. So let's go ahead and do that. So 25 is equal to 50 e to the K times 14.3. Same thing that we did with the previous example. We're going to divide, and it's going to give us 1/2 equals e to the 14.3K. What do I do now? Well, property of logarithms, bring this guy down. So I'm going to take the natural log on both sides. Okay, ln. So this is going to be 1/2 e to the 14.3K. Now with that, this guy is going to come to the front. So I'm going to have ln of 1/2 is equal to 14.3K times ln of e. And remember, ln of e is 1. Okay, so this guy becomes a 1. Okay, if you plug that in the calculator, you'll get just 1. Now, what do? Well, you're going to have ln of 1/2 is equal to 14.3. Okay, you're just going to divide everything by 14.3, and you're going to plug it into your calculator. Okay, 14.3, and that should give us approximately, let's see here, negative 0.04847. And that's the rate at which it's decaying. Now that I have that information, okay, this is what I got. Now I can figure out how much the amount that's remaining after 84 days. So it says first, write the exponential decay function. Okay, so my decay function, we'll call that part A, is A equals, well, I'll just write the whole thing, A sub 0 e to the kt. Well, what did I start with? I started off with 50 milligram sample E. There's your k factor, negative 0.04847 times t. That's my general equation right there. Now, the second part is, well, after 84 days, how much is left? Well, I'll just plug in the 84 there. So A is equal to 50 times e to the negative 0.04847 times 84 after 84 days. And that's going to give you approximately 0.8526 milligrams. And it makes sense because, you know, this amount of element is decaying. But hopefully that makes sense, guys. So start off, label it, okay, write it down. And then as soon as you see half-life, okay, what do you start with? 50, half of that is 25, gives you the time frame. But a lot of times you're going to have to find k first, okay? So hopefully that helps you out. And then after that, you have your general equation. And with that, you're able to just plug in your time period and you're able to solve the problem. All right, guys, hopefully that helps. I'll see you guys next time.